Alright, so let's pick up from where we left off. I wanted to do this also. You do notice that all the bases are the same, but that's okay. I still need to combine my right hand side so that log 3 of something equals log 3 of something, so I can equate the inputs. So I leave my left hand side as it is, and my right hand side is 1/4 becomes, you raise it to log base 3 16 raised to the power of 1/4, which basically means you're looking at the 4th root of 16, which is, we should all know what that is, and log base 3 of 64 and the cube root of that. 1/3 basically means the cube root. So my left hand side remains the same, nothing happens to that. This can be rewritten as log base 3 16, 4th root of 16 is nothing but 2, because 2 to the 4th power is 16. We should all know this. And then 4 cube is 64, so this is nothing but 4. And then what do I do to 2 and 4? You multiply, because it's an addition. So this is nothing but log base 3 of x equals log base 3 of 2 times 4 is 8, which basically means x equals 8. This one was easy. The last step was easy. And you go ahead and do the check. It should work because I don't think you're getting a negative value. So log base 3 of 8 equals, you go ahead and do this. So this is a valid value, so it is okay. It is okay. Let's go ahead and look at this problem. So this one also, I see that the base is the same and they're all on one side. So I can actually condense this. So I will rewrite this as, you have to kind of see what's happening here. So this is log base 8, this is log base 8, and there is a plus sign. That means I can combine these two by multiplying. So when I multiply, I get x minus 3 multiplied by x plus 4 equals 1. Now what am I going to do? So I'm finding that x is the input for the log. That means I want to make that the output. So what I'll do is, let me go ahead and multiply this actually before I do anything else. So when I multiply x minus 3 and x plus 4, I actually get x squared plus x minus 12 equals 1. And now I'm going to rewrite this. So 8 is my base, 1 becomes my input, and this whole thing becomes my output. Rewrite this in the standard quadratic form. So x squared plus x minus 8 comes to the other side, becomes negative 20 equals 0. And then this gets factors of negative 20 that add up to positive 1 is x plus 5 and x minus 4 equals to 0. That means x equals to negative 5 and x equals to 4. I can straight away cross this out because negative 5 minus 3 is negative 8. I can see that it doesn't work at all. But hopefully the 4 works. Log base 3 of 4 minus 3 is valid, plus log base 3 of 4 plus 4, 8 equals 1. It looks like a valid statement, so it works out okay. Alright, moving on to the next page. Hopefully you could see this. More of the same thing. I should be able to, sorry, I'm waiting for this, losing focus. Yeah, okay. So you should be able to combine these two into one element because there is a negative sign. I'd like all of you to look at the key. It's actually pretty similar to what we've done. So they will get combined, but they'll get combined as a division equals to half, and then you do the same thing that we did in the previous problem, and you should be able to do that. So go ahead and take a look at the key and see if you can work this out. So let's look at example 4. So example 4 is a word problem that we have done before when we introduced E, except at that point, okay, I'm trying to see if the focus comes back so that you guys can see what we're doing here. Oh, there we go. I thought it was coming back. Nope. All right, excellent. Let's come back. So you deposit, okay, so it says you deposit 2,000 in an account that pays 2% annual rate compounded continuously. So remember guys, when we did compounding continuously, our formula was The final amount is based on the principal with the base ERT. It's called the PERT formula. P-E-R-T, PERT formula. This is the formula when you do the doing continuously. I'm trying to see why we're losing focus constantly. All right, let's hope that it doesn't lose again. All right, so now let's substitute and let's go ahead and solve. So okay, let's finish reading the question. How long does it take the balance to reach $3,500? So this is my final amount. So what I'm calculating is I'm calculating the time, because how long does it take? Okay, let's substitute everything. 3,500 equals, my initial amount is 2,000. E is a E is a number, so E stays as E. My rate is 2%. So 2%, remember you write it as a decimal, so 0.02 and a T. Now what do you notice? You notice that the variable that I'm trying to solve is an exponent. So I can try to, first of all, let's make sure that we get this E by itself. So I will divide both sides by 2,000. So divide by 2,000, divide by 2,000, left hand side and the right hand side. So 0, 0 gets cancelled. 35 by 20 is nothing but 7 by 4 equals E raised to the power of 0, 2 to the power of T. So somehow I have to extract this T from here, which is basically an exponent. So I can convert this to log. I can rewrite this as a log. So for me to rewrite this as a log, my base will be the same. So my base is E, so which is ln. And my input will become the output here, so 7 over 4. And this was my input for E, so that becomes my output. So T multiplied by 0.02. So my final answer is T equals ln of 7 over 4 divided by 0.02. Go ahead and put this in the calculator. Make sure that you're putting your parentheses correctly, and you should get T to be approximately 27.981, or we're looking at 28 years. It's going to take him 28 years for the money to grow to that amount if the interest rate is 2%. Alright, so hopefully we got the hang of it. So you should be, by this time you should be able to go between logs and exponents to be able to solve equation. And the last topic for this lesson, actually for this day and for the entire lesson, because we are stopping at day 5. We will start unit 8 next class, but let's go ahead and do this. So this actually should not be too difficult. So finding inverses, we are doing this because remember, logs and exponents are inverses of each other. So if you're given a log, you should rewrite it as you can rewrite it in the exponent form if you're asked to write the inverse. So what are the steps for finding the inverse? It's the same step that you do for finding any inverse. So the first step is switch x and y. And the second step is get the new y by itself. And this new y by itself is the new f inverse of x. Alright, so these are your two steps, step 1 and step 2. Alright, so let's go ahead and look at this. F of x equals log base 4 of x minus 5. But in a lot of times, it's given as f of x. I just like to rewrite it as y, so it's clear for me. But you don't have to, as long as you understand that f of x is nothing but y. But now I do the first step, switch the x and y. So this becomes my x, this becomes my y. Now your goal is to get that y by itself. How do I extract this y, which is an input for log? We do the opposite. We rewrite this in the form of exponent as long as this is by itself, which it is. So my base is going to be 4 to the power of x equals y minus 5 becomes the output. I hope everybody understood how we did this, right? 4 is my base, this becomes my input for 4, and y minus 5 becomes the output. You switch the input and the output. And now remember, you still haven't got y by itself, so y equals 4 to the power of x plus 5 because the 5 moves to the other side. So this is my equation, but this can be written as f inverse of x equals 4x plus 5. So this is your inverse, this is your original function. So my original f of x is log base 4 of x minus 5 and f inverse is 4 to the power of x plus 5. Alright, let's do one more because this next one is an exponent, so you need to rewrite this in the form of a log. So let's see how we're going to do that. So first step is to rewrite this as y equal e x minus 1 plus 2. Switch the x and y, so this becomes x, this becomes y minus 1 plus 2. Your goal is to get this y by itself, but first let me move the 2 over. X minus 2 equals e y minus 1. Now you want to extract the y, which is the input, you want to make that as the output. So you will write this with a base ln. So base ln, the input is x minus 2 and my output is y minus n. So y equals ln of x minus 2 plus 1, which is nothing but your f inverse. That is your inverse function. Alright, so hope we got this, and the lesson for today is over.